Once you get familiar with all the tools that you can use to model something in Alibre, I think it's important to also talk about the design intent and also the capabilities that Alibre has when you have good design intent. For instance, here we have a 5-lug, 5-spoke alloy wheel. Now I can update this. Now simply by changing one number, I can go from a 5-lug, 5-spoke wheel to a 6-lug, 6-spoke wheel, as we'll see in a moment. Indeed, Alibre has the capability of changing almost any aspect of this wheel and doing so instantly using equations and good design intent. So let's talk about how sketches can be made easier to interpret and work with, and also easier to update, as well as implementing equations to quickly configure and change our part. So from the default modeling environment, why don't I open my equation editor and ask myself, what do I intend to do with these dimensions? And I'm going to say I want to change my wheel and configure it in ways that it can quickly be adapted to fit many different kinds of automobiles. And to do that, I just have to add some parameters that reflect the dimensions I want to change. Right? Wheels are often defined by a bolt circle diameter, which in this case I'm going to say 114.3 as a starting default. Now I'm in inches, so I'm going to divide by 25.4, and that is a distance. I also would probably want to define my wheel by offset, which I'll just write in all caps, and I'm going to say my offset would be something like 1/4 inch, which I can change later, and again define this as a distance. Next, I might want to say my wheel diameter, and I can make that something like 20, and again, distance. I can want to define a wheel by its width, which I'll say is 9. And then BCD offset diameter width. I might want to say the number of my lugs and spokes. So maybe we'll say spokes and holes. Again, you can choose a variable naming convention that works for you. I'm being quite basic here. Let's say I'm going to intend to make a 6-lug, 6-spoke hole to begin with. Now I also want to make sure that this is a count and apply that. And finally, I'm going to make a variable called angle, and this will be 360 divided by, and I want to choose my spokes holes variable, and I want to divide that entire value by 2. And whoops, I typed the wrong parenthesis there. I want this to actually come out as an angle, and I'll notice that if I apply this, this comes out to 278.873 degrees. Well, 360 degrees divided by 6 divided by 2 should be 30, not this number. And that's because Alibre is defaulting to radians. So I'm just going to add in an easy mathematical conversion where we say times pi divided by 180. And that becomes the predictable 30 that I was going for. So I'm going to mark all of these as my favorites. And just by changing these values, I can get this wheel to fit just about anything, in theory at least. So we're going to say OK. And let's go with sketching on the ZX plane. And when we sketch on the ZX plane, we'll start talking about some easy design intent, right? So we start a sketch, we'll make a rectangle, I'll make one of these parts horizontal, and then I'll add a dimension, 1.25, and then I'll add a dimension here and say 3, right? Now, is this 1.25 dimension critical? Well, this wheel is probably going to have a hole through the center of it when I'm done, so as long as I define this to be less than the final diameter of the hole, I should be fine, because I'm planning on extruding a hole. So I think it makes sense to have this 3 connected to this origin here, right? Now if I delete this 3 dimension and add my 1.75 dimension here. If this gets changed, you can see this whole outer wall is going to change depending on how I change this inner wall, and this inner wall is non-critical. So it's important to think that this outer wall dimension would be a lot more critical than this inner wall dimension. Thus my intent is to dimension it for now relative to the origin. And that way I can change this however I wish, and it won't be affected by other dimensions. This is the kind of thought process that goes into a design intent, and we're even going to revisit this 3-dimension before we're completely done with the video to show something that I think is even a better solution. But for right now, let's move on to something and keep things interesting. Let's define a plane, and this is where my angle dimension comes in. We're going to make this angle, and I'll click reverse, right? So that's our 30-degree angle dimension. And what am I doing here? Why, I've told Alibre, or at least the equations editor, that I'm going to make 6 spokes and holes. And so the angle between here and here is half of a sixth of a rotation, right? So then I can mirror this to get a sixth of a rotation. So I'm going to build a sixth of a wheel and then pattern the other parts of it for design intent. If that's confusing, stay tuned, and I'm sure it will make sense by the end. We'll make a rectangle now. We'll go with a vertical to there. I'm going to take the same dimension here, and we'll say 1.25. Likewise, we'll come across here and say 3. Same dimension, 0.5. But let's say I want this line to be angled. I'm simply going to click on that vertical relation, hit the delete key, and now I can adjust it. We'll add a dimension to this line, and we'll make it something like 1.75. From here, maybe that's a bit tall. I'll take it down to 1.5. From here, let's do a loft. So we'll loft from this profile to this profile, and we're going to specify tangents in both, and I'm going to say 0.3 for a magnitude of both. There we have it. Next, I can choose this face, and I'm going to choose mirror, and I'll choose this plane. And so this is 1/6 of that center of our wheel, right? Because we specified the angles here to work out to be a sixth. If I change this value to, say, 5, which I can simply sort by my favorites, come up here and say that my spokes are it's going to be a 5 spoke, then these update to be a 1/5 of a rotation. I'll stick with a 1/6 right now because 30 degrees is such a nice round number. So we're going to say 6 again. And what can we do? Well, I want to make a few planes that define parts of my spoke. So I'm going to make a plane that is offset 3.5, and I'll hit reverse and back. So this plane is 3.5. Let's define this plane, and I'm going to say diameter, right? I'm going to use one of my variables and divide that by 2. So now I know that my spoke is going to go at least the entire radius of my wheel, which is enough distance. And if I change the diameter of my wheel, the profile of my spoke, at least at the end, is going to change as well, which I think is super helpful. With these defined, let's talk about more sketching design intent. I have 3 profiles to make to define my spoke. And how about I make 3 sketches in sort of different styles that will do hopefully a good job at illustrating what you incur with good sketch design intent and less relevant sketch design intent. I'll start by making a profile here. Let's make a kind of a triangular profile. I'll make an arc, and you can also use tangent arcs with lines as well. That works too. But I'm going to take my 3 arcs and connect them with lines. And let's grab a tangent constraint. Let's make all these arcs and lines tangent. Smooth profile all the way around. Excellent. We're going to say vertical on these points here. Let's grab a perpendicular from here to here. And then I'll grab an equal on all these arcs. Looks like that already exists. So from here to here will be equal as well. That happens sometimes. I'll just Control Z and adjust this a little bit more, and that won't happen. So equal from here to here. Perfect. Next, you know what? Maybe I'm going to change my intent a little bit. I've got a line right here. I think I'm going to make an arc whose center point is around here. And I'll again re-add my tangents from here to here and from here to here. Next, let's add a dimension. That's going to be something like 2.65. And then I'll make this 0.25. And then maybe center to center here, I'll go with 0.75. And maybe I'll make these centers here something like 1.5, right? And we're fully defined. So this is a pretty typical way of dimensioning things. We, of course, have an arc radius, and we define arc location by their centers. Nothing all that unusual. And we're primarily relying on constraints. Now this makes it pretty easy because we dimension it the way that we measure things usually. So usually QC will measure arc centers and determine center-to-center distance between important features, and we've defined the center-to-center distance between important features. I think this is very standard design intent so far. So we'll deactivate the sketch, and we'll notice that I think it's relatively easy to update, right? We have a perpendicular angle defined, which shows kind of a design intent for our starting profile, and I think it's pretty readable to know the center-to-center distance and understand what the spoke looks like and how to update it. We'll deactivate the sketch. Now we'll come here and make our second profile, and let's draw this to be similar but just a little bit different. And this time I'm going to start with 3 lines, and of course I can terminate my line by double clicking, and then I think I'll draw another line here and another line here, and I'm going to choose a tangent arc like I talked about before. And that one is a little bit out, so I'm going to move my line, right? So tangent arc from here to here and here to here. Let's go with tangent, tangent, and tangent. Next, let's start dimensioning this. Let's say I want my center of my arc relative to my origin here to be something like 0.9. Maybe I'll choose this point and this point to define the length of my line to be 2.149. Now you'll notice how I did that, and there's a reason why I've done that, right? Because you might look at that and say, well, isn't it easier to just click the line and set the dimension? And it is. Here's the difference between clicking the line and 2 points that make up the line. When I go back and let's say edit this sketch and I delete this line, then all these things are undefined because we lost that dimension. If I draw a new line, and if I make a dimension from point to point, and I go and edit this sketch, maybe just like in the last sketch when I deleted a line and added an arc, if I want to do the same thing, I still keep this dimension, right? The dimension disappeared when I selected that line before. So it's best practice, if you wish to keep your dimensions, which you almost always do, to use dimensioning on points instead of lines. And that is true for many different disciplines. All right. So I was able to re-add that line and keeping my dimension. let's say from this origin to here, I'll make it 1, and then I'll make this 2.0. Well, how about I'll make this dimension 0.206. I'll make this radius 0.372. I'll make this radius 0.214. How about relative to my origin? I'll give this something like 0.742. And we're fully defined. I didn't actually intend to have this equal here, so I'm going to get rid of this equal, and that's going to cut down on my fully defined for sure, but this is my 1 degree of freedom, right? And so I'll choose my point here and my point, and we'll say 0.132. And we're fully defined. So what have I done here? Notice I have this one dimension that seems to define where this point is, and I dimension off of this point to define this point. So I've got sort of a chain going, right? A daisy chain where this one puts this here, and then this goes from here to there. And so it can possibly, this isn't wrong, but there's possibly some ways that might make it more simple, depending on if I care about where these points end up, or if some other profile is more important to me. Another thing I did is I made non-standard radii, right? 206, 372, 214. 214 is so close to 206 that it's probably worth it just to standardize as many dimensions as possible, right? If you're going to CNC out a pocket and you have different size radii, maybe you might need different size tools to do that most efficiently. So standardizing things can have a lot of implications on how the part is made, as well as how the part is understood. Maybe I do need a 206 and 214 here, even though they're so close. That is for you to decide because you're the engineer, but this could cause some confusion on how this part is portrayed, or at least unnecessary complication. Next, I defined this point by 0.742. Does the location of the center make sense to the person who is making this part, the person who has to read the drawing, or does some other dimension matter, right? What if cosmetically the angle is a very important factor? It makes more sense to directly dimension whatever angle this profile is, and if I go to update this sketch and make this 10 degrees, right, I can pretty well predict what the behavior of these elements are going to look like as I adjust them. Now if I come over here and restore my 0.742, then adjusting the XY location of an arc may be a little bit less significant to a user in terms of what this profile is going to look like, or the ease of dimensioning this profile. I also want to say I have 1, 2, 3 lines and 1, 2, 3 arcs, and I have 1, 2, 3, 4, 5, 6, 7, 8 dimensions to define all that. And if I deactivate my sketch and say I've worked this out with 8 different dimensions, and I edit sketch 3, I have the same thing, 3 lines. Actually, I have 2 lines and 4 arcs, but the same number of sketch elements, and I have 1, 2, 3, 4 dimensions. So in half the dimensions, I am able to fully define a similar or even equivalent profile that I was before. So another principle of design intent is that the fewer the dimensions, generally the better updating and more simple to interpret, right? This is a little bit more intimidating than that other sketch that I made. Even though arcs are a little bit more hard to define, I think the other one is a lot easier. So hopefully that is helpful when we talk about design intent in sketching. Now let's make our final profile, and I wish to make that in another way still. Let's make an arc, another arc, another arc, and let's go with a line, and a line, and a line, and we'll go with a tangent, and a tangent, tangent as before, tangent, 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 tangent. All right, now we're going to grab dimensions, and I want to dimension the center of this arc, right? We're going to say something like 4.330, and then let's add a vertical dimension here, and I want to say something like 3.104, and then we'll come to this, and we'll do a vertical dimension, and we'll say something like 4.26, and then we'll make a horizontal dimension, and we're going to do something like 3.779, and then we're going to do another horizontal dimension. I want to do something like 2.793, and then we'll do a vertical dimension here, and we'll make that something like 3.068. Next, I want all of my arcs to be, let's make them all equal. If you hear my toddler, she's fine. We'll grab a dimension here of 0.5. So with this full definition, you can see we've taken 7 dimensions to define this, when again before we were at 4 with a very similar profile. And when I go to update this, right, when I make this 2.793, what's it going to look like if I put a 3 right here? Right? It's kind of hard to predict, I think. So it's unclear to just define the X and Y on a lot of things as to how things are going to update when you try to account for the location of all these other dimensions and when they don't update. So I would suggest, again, using design intent with as few dimensions as possible and relying on constraints which are very predictable and very easy to work with. So hopefully this sheds some light on some principles of good design intent as far as sketching goes. Let's deactivate our sketch now and run a loft. Grab my loft from here to here to here, and let's say that my tangents you can tell I've narrowed out that profile quite a lot just by specifying tangents, which I really appreciate Alibre for. So I'm going to say my magnitude is going to be 1, and let's do 1 again, and I'm going to say 1 again. And that makes, I think, quite a beautiful spoke profile where it's kind of high on this side and then it gets to be high on this side. I think it's a nice spoke to look at. Let's do a few housekeeping things, right? So I've got my YX plane. Let me reset my view here to go to the other side. I'll choose my circle. And from here, let's do something like 2.75. Whoops, 2.75. And I can do an extruded cut, and I'll simply say through all. And that will smooth out and make our center very round. Let's add a lug nut hole, right? So I'll activate a 2D sketch on my XY plane. Again, I'll reset my view. I'll grab a circle, and I'll grab my line. And I want to dimension the angle of this to be 16 degrees. We're going to go with 0.5. And then I have my bolt circle diameter defined, BCD. But of course we're dimensioning from the center, so I'll simply divide that by 2. And there's our bolt circle radius. And now let's deactivate the sketch and extrude again through all. Now a lot of these wheels have kind of a step inside, so let's define a plane to be 0.25 right in the middle there. and I'll create a sketch on that plane. Again, I like this side, so I'll reset my view. I'll choose a coincident constraint, and we choose this circle and this hole to be coincident. And then on my dimension, we'll say 0.75. How about? We'll deactivate the sketch and use an extrude cut. And that depth works fine for me. So now we can add a chamfer in there if we wish to make it much more like a real wheel. Next, and this is something that's a little bit interesting, right? We have multiple options that we can do. As you can tell, we are staying true to building a fifth of a wheel so far. I can take this XZ plane, activate a 2D sketch, and I can start making a wheel profile. I can make my profile, I don't know, some kind of generic wheel profile will be fine here. I'll grab my equal and make sure that these are equal relations, as well as here and here. I might have I unintentionally made these lines equal, so I'm going to delete that. And again, we'll make sure that we are equal from here to here and equal from here to here, and that's much better. That's the design intent that I want. We'll go to 0.5, how about? And then from here to here, we'll set our actual wheel radius. And you might want to go from this outside point, up to you. We'll say something like diameter, but we're dimensioning from the center, so we'll divide by 2. And then we want to set our width. So come here to here and just type in width, right? And as I update these dimensions within the sketch will change to help us define our wheel. Now we're going to go with something like, I'm going to say 150 degrees. And we also want to define our offset, but maybe I'm getting ahead of myself. I'll just enter a few more dimensions, right? 1 inch here. And then I can click and drag to see where else I'm not defined. So as my width changes, right, I imagine that, you know, if I type in an 8 here instead of a width, this angle changes. Do I want this angle to change, or do I want this line to get shorter? All right, that's design intent. When this updates, how do I want things to update? I'm going to go with leaving this angle consistent so that this line, which is pretty non-critical, can change as it wants to. 135 seems to be a great angle, and I'll make this something like 1. And then where else am I not defined? Simply by my offset, I think. So, how do I define offset? That'd be the center of my rim relative to my mounting face right here. So we'll go to line. We'll make a vertical line that goes from here to here. And I guess that also helps with my design intent that I can define this one as vertical as well. And now it's truly just our offset that we need to define. Oh, and I'll make these lines equal to make sure that they are actually marking the center. So now as I move this up and down, maybe I'm going to start off about right there. Right, so I choose my face here and I choose the center profile. I'll make that 0.0, and 0 offsets do exist. I think they're pretty common. Let's say 0.125. Don't even know if that's a real or standard offset, but I think it'll work here. Next, Control A, I'll just highlight everything and I'll hold Shift to deselect my construction lines here. And I'll choose an offset and I'll simply flip my direction to get a profile here. Now, it is always best form and it is always best as design intent to always fully define your sketch. So we're going to say okay, and let's head back to our 2D sketch. So I'll fill in this line here, this line here. I'm going to leave part of this sketch undefined to try to illustrate what I think is going to happen if I don't fully constrain. So full constraints play a huge part, and I'm going to choose parallel for these angled lines here. Okay, good. That's probably gonna not, oh, yep, that's good. Great. So I think that's everything that I'm going to do, and I'm going to leave part of this undefined to hopefully illustrate what happens when you don't fully define things. Next, let's do a revolve, right? An additive revolve. I select my axis here, and I can go all the way around, and there's nothing wrong with going all the way around. In fact, I think I recommend it. But let's just do something kind of interesting to show a few ways of achieving the same thing. In fact, I think my angle's good there. Yep. In fact, I need to multiply that by 2. So let's go back here, edit. So if I do the revolve all the way around, then we've completely made the feature. But here I've made only what either a fifth or a sixth of what my wheel is. I forget what value I'm at now. And that should be interesting moving forward. So when I go to make this, I can choose a circular pattern. And in instances, I'm going to say something like spokes, holes. I'll do an instance pattern and define my center. And then I can define my loft and my mirror and my cut. We'll see if my cut works. Yep, it does. My spoke, and then my hole, my other hole, and lastly my revolve. And just because I pattern a revolve a fifth of the way around or a sixth of the way around, and then I'm patterning it that same number of times, orientation really doesn't even matter. Here we are able to generate a full profile. So it's interesting that Alibre gives you so many different routes to achieve the same thing. And that is what design intent is. You have many routes to get to where you want to go, and design intent is choosing what would be the most efficient way to get there, the most understandable way to get there, the most manufacturable and measurable way to get there, the best defined way to get there. Right? All these things kind of add up to being what design intent is and what's easy to update. So let's create a sketch on this plane, because I have a bunch of spokes that are poking through my rim, and I don't want that. So I'll choose project a sketch. I'm simply choosing the inside of my rim. That creates a good profile. And I'll maintain association, and we'll grab a line, and we'll move up. And I'll move up on this side. Let's see here, we'll reset the view and make sure that we are horizontal and vertical and coincident from here to here. And then we're going to go to dimension, and we're going to say something like 6. And then we're going to deactivate the sketch, and we're going to revolve cut on this axis. And of course it has us going a sixth of the way around, so I want to go 360 and OK. So we've cleaned that out OK. Except we do have a little bit left over from our cut. So I think this offset might be a little bit unrealistic. That spoke is a little bit over there, so instead of trying to correct that extra little bodies that I've got, let's change this with the equation. So I'm going to sort my favorites to the top, and we have our offset right here. How about I make that negative 0.25? So nothing happened there, and I think I know why. Again, another part of design intent here. Let's go to our revolution and edit the sketch. in terms of offset here, yep, that looks like my offset. I needed to define offset, right? So we'll close that, and there's our 0.25 offset that I was looking for. Perfect, so we'll deactivate that sketch, and now if we generate to the last feature, we ought to be in business. So that part of design intent is when you decide to have design intent, you should absolutely do put it in the model so that it shows, right? We'll go to our equation editor now, and let's just see how design intent updates. Let's sort the favorites. And we'll come up here to offset, and I'm going to say 0.125. If you watch kind of where my mouse is, there you go. So we've had an adjustment in our model. Now, of course, I just brought those bodies back when I had just gotten rid of them. So let's come up here, right? Sort the favorites. We'll come up to offset, and I'm going to say negative 0.4. And we'll see where that puts us. Excellent. I like that. I think that's about the perfect dimension for that wheel. Next, let's edit our width, because I have an agenda for editing the width. We'll come up here, and our width, let's make that something like 10, and go with a 10 by 10. And you'll notice this lip turned out fine, but look how big this lip is, right? If I go back to my revolution, it just so happens that when this dimension lengthened, this line lengthened with it because I never defined what that dimension should be. So you can start to see the problems that you run into when things are not fully defined. So let me take this dimension here, 0.125 is good. I'm going to say equal from here to here, and we'll just finish up with our design intent here. And we'll make sure that this is horizontal as well. Now we're fully defined on that sketch, and our wheel looks much better. So we'll generate to last feature. Finally, maybe we'll try the big one. Let's go from 6 spokes to 5 spokes and see what happens. We're going to go to equation editor, sort out our favorites. We'll make this 5. And it updates very nicely. Notice there are no errors in the tree. So we were able to do quite a lot and have quite a configurable wheel that will fit a lot of cars without too much effort. Now, when we were sketching in this sketch right here, I said that I would have even another way of doing things, which I would like to illustrate now. If I change my bolt circle diameter, which I should do from our editor here, we're at 4.5 right now. What if I stretch this out to 5? What does that look like? So you can tell we're getting kind of thin up here. So maybe we want to define this wall not relative to the origin, right? Let's jump back in here and see what we can do. I'll go to my sketch. We'll edit the sketch here. And instead of 3, let's say BCD divided by 2, and that distance will take us straight to the middle of our hole. And then what if I said something like plus 0.75, and that would mean that we have at least 3/4 of an inch away from our hole at all times. Let's do that on our next sketch, sketch number 2. We're going to say BCD divided by 2 plus 0.75. And we'll deactivate that sketch. We'll generate to our last feature. And now we have a pretty good thickness away from the center of our hole. So if I go to my equation editor, and I go to BCD, and I make that back into 4.5. What does that look like when it updates? This wall will shrink with the bolt circle diameter. So now, whatever wheel that I produce, this thickness will always be the same, which I think has a lot of merit to it when you want to consider having something like a minimum strength that you're working with. So that's design intent, right? It shows how I intend things to update when something changes. And now I can configure this wheel to be pretty consistent and fit on a very wide range of automobiles just by changing some numbers up here. This is made possible not only with good design intent, but with Alibre's equation editor, which I have found to be quite easy to work with, and I've enjoyed doing so. Now I think this wheel looks a little bit better in 6 spokes, just due to the spoke width. So I'm going to treat myself and make sure that it is a 6. And one more thing when looking at patterned objects and design intent. Let's add a fillet to these edges. I'm actually kind of impressed at how much this fillet can fillet and not be interfered with by this face here. So I've created a fillet. I don't believe there are any problems with the wheel, so we'll close that. And when I come here and we say favorite, sort, 5 spokes there, and we update this into being a 5 spoke, something peculiar happens here. We get an error right here in fillet number 14. And why does that error exist? And notice our fillets don't exist anymore. If I go to my status, this may be kind of confusing, but it's saying target is no longer available. That's because I selected 6 edges in between my 6 spokes. Now there's only 5 edges in between my 5 spokes, and Alibre is saying, I'm trying to add the 6 fillets that you put in, but there's only room for 5 fillets, right? We have an edge that no longer exists that should have a fillet on it. Therefore, I can't make the fillet, and so I'm going to error out. So that is one precaution to be careful of in design intent, and also something to be cognizant of in your design intent. How will this update when changes are made? That's a big question. How will someone else understand this when they take this model apart and take a look at how I made my sketches, right? That's another important part of design intent. Another thing to ask, how manufacturable is this part? So hopefully this exercise has been useful in seeing how easy or difficult things can be with the right amount of design intent added, and how much fun it is to be able to type in numbers and reconfigure your wheel whenever you wish.
Hey, quick question for you. Are you happy with your current job or career? Do you like going to work every day and see yourself doing what you're doing right now forever? If not, I'd like to share with you a little bit about the sponsor of this video, the Programmer Coach. The Programmer Coach is an online coding program that helps people learn how to code and get a high-paying job as a software developer. Their program is unique in that they teach you how to code by doing through practice, which is truly the only way to learn any skill at the end of the day, right? Plus, they provide you with coaches to help you whenever you run into any issues. They also have career coaching and placement services, where they work with you and help you get your first job as a software developer. And the best part? Their program is affordable and accessible for anyone and everyone. That's right, you won't pay the bulk of your tuition until you actually land a job as a software developer. To learn all of the details you would ever need and get all of your questions answered, simply go to becomeaprogrammer.com. Once again, that's becomeaprogrammer.com.